Hello everyone, welcome to DecodeAIM, and in today's video we are going to solve our next problem, which is valid anagram. So this problem states that we have been given two strings S and T, and we have to return true if T is an anagram of S, otherwise we have to return false. So at the very first I would like to tell you what is an anagram. So if you hover over this, then you will see a definition. An anagram is a word or phrase which is formed by rearranging the letters of a different word or phrase and using all the original letters exactly once. So let me give you an example, very simple example. If you see here, we have earth. And if I tell you we are creating an anagram of this, then we can write something like HEART, which is heart. So earth and heart contains same set of characters, but they are rearranged into something other meaningful sentence. Like earth, so it is EARTH. E is exactly one time, and here also E comes exactly one time. A also, RTH, and all those are present in heart. No extra, no less. Alright, so let us come towards the problem and see example 1. Like here they have given ANAGRAM. So here T string will also contain NAGARM, which is rearranged but contains exact number of characters as S is containing. So let us come towards the brute force solution of this problem. I will give you 1 minute to pause this video and think of the solution in terms of loops. Alright, I hope you might have got your solution, but if not, then let us follow along. In the brute force approach, we have been given two strings, C, S and T, and we have to check if T is the anagram of S or not, or they are anagram of each other or not. So if I show you something in terms of you can say something like this, we have EARTH and we create HEART, and suppose I say here one more E, then you will see this string is containing 5 characters, 1 2 3 4 and 5, whereas this string is containing 6 characters. So the very first check in your mind should come in terms of length of the string. If the length of the string is not equal, then we cannot even say that it will be an anagram. It is clearly stated that some character is extra in that particular string, which is having more length as compared to the other. So the very first check we will do is that if the length of S is not equal to length of T, then definitely we will say here that this is not an anagram and we return false. There comes the actual solution in the brute force approach. Now let me tell you how we will approach to that solution. So first of all, the S string is containing some set of characters, whereas T is also containing some characters. So if I iterate over each character, and say that that character is present in the second string, that is T, and if that is present, then I simply remove that character. What I'm saying, if that character is present in S, I simply check it in T also, and if it is present in T also, then I remove that from T. So something like that, EARTH, HEART. Now I'm saying that is my E present in this set of string. So yeah, T contains E here, so I removed it. So now it becomes HART. Once again I check, is A present there? Definitely. Now it becomes HRT. Now once again I check R. So R will be cancelled out and it will become HT. And if I check here t also, then t will be cancelled out, and in the same manner h will be remaining, and lastly h will also be cancelled out. So here at the very end the t string will be an empty string, or you can say in terms of like this. So it will be an empty string. It will not contain any character in that. And this proves that our two strings are anagrams of each other, because on the right hand side you will see t string from the very beginning to the very end has become empty, and on the left hand side also you will see the s string has been cancelled out and become empty. So definitely this proves that we have the anagram s and t are anagrams of each other. So let us come towards the exact solution of this problem. After checking that my length of the s and t are matching or not matching, then we come towards the for loop. We run a for loop and say that for character, I am stating a variable ch in s, checking each character in s, and I am saying if my character is present in t, if it is present in t, then I run a replace function. What I am saying, if my character is in t, then t equals t dot replace the character with empty, and I did over to the next. Now else I return false, because if it is not happening, then it is not an anagram. And at the very end, if all become empty, then the strings are matching, which means it will return true, and we have our valid anagram. If you see here how this is working behind the scene is exactly like this. Very first, if character in t, so ch will have e as character, and it will say if my e is in s, I iterate over the character, so ch is pointing to this right now, which is having the value of e. So if e is in t, then replace e with empty, or so it is saying that cut it from here and it will remain HART. Furthermore, go ahead and repeat it over the time, and then you will see it will be an empty string. And then if everything becomes okay, then it has to return true. Otherwise, if this statement fails to follow, then definitely this character is not present in t, and hence we can say with only one character which is not present in t is that this is not a valid anagram of s. So this particular solution is exactly the brute force approach that we are going to solve for valid anagram. And let us come towards the solution and solve it right in front of you. So what I am saying is that first of all I have to check is the length of my s is equals to length of t, and if it is not true, then I return false. If it is true, then I return false. Now coming towards the for loop, if my character is in s and if character in t, then I replace it with I'm sorry about that. So then I replace it with empty, and otherwise I see that this is not a valid anagram and I return here false. At the very end, if everything is okay, then I simply return true. And let us run through the code and see is it working. Well, we have passed the test cases, and if I submit it, I will see here that we have solved a valid anagram problem using the brute force approach. Now let me bring you towards the exact time complexity and space complexity that this solution will have. So if you see here, this is order of 1 time, nothing it covers. Now coming towards this for loop, simple. You now on you can get this that it is order of n times. So it is iterating over to the whole length of the string. Coming towards this if statement, Okay, all right, but this is dependent on that for loop. This whole block is dependent over that for loop, right? And this character is being checked over and over to the whole string. So this whole you can simply say that it will also be running till order of n, because t can go till order of n, right? And everything goes well, it returns true, order of 1, order of 1. Then you can see that the time complexity here is something like order of n into order of n. So it will be order of n square. And in most of the array based questions, you might have seen that this order of n square is very much common. That is why we have to optimize this problem to further more, right? Now this was the time complexity. Coming towards the space complexity, so here we are not using any extra data structure to optimize the memory, so it is order of 1, right? This is okay. Let me come towards the mental model that we used to give. So the mental model here is that you cut one letter at a time from t. So you are checking that character from s and you are checking it into t, and you are cutting it at a time from t. If all matches means the last it becomes empty. If all matches, then it is an anagram. Good, then it is an anagram, right? So this was the mental model for the brute force approach. Let me quickly introduce you the optimized version of this, a little optimized version of this. We will be doing it in 3 iterations. The first one will be brute force, second one will be the sorting approach. So let me introduce here one more approach to you, which is sorting based. If can we do this using sorting? So let me quickly write the heading here, sorting based. So, and yeah, this is optimized, this is a little optimized. So this is like we cannot say it an optimal approach, but it is better than the brute force. Okay, so we can say it here like better than brute force, better than brute force, right? And my dear friends, this is a one-line solution only, because Python function has its own sorted function. We can use it like this, sorted. Very simple, very simple. We have something, we can check this sorted of s along with sorted of t, and if everything goes well, then definitely we return. This is the solution, but I would like you to know the exact approach why we are doing this. So let us come towards once again the example. EARTH and HEART. If I sort this string, then it will be something like A, E, and further it will come to, I think, R or T, H, R, and T. If I sort this heart also, then I will be getting exactly in the same manner A, E, H, R, and T. And I am saying that if this sorted and this sorted strings are equal to each other, then definitely I return true, and this sorted and sorted will be returning something like true, so it will be returning true eventually. And you guys now know that sorting and the most optimal sorting algorithm contains order of n log n complexity. And because of that, the time complexity becomes order of n log n, and whereas the space complexity can be order of 1 or order of n also. Why order of n also? Because it depends on the how we are implementing the sorting approach, right? So it can be order of 1 or order of n. But coming towards the time complexity, it is exactly order of n log n. So if you see here, we have optimized this approach from order of n square time complexity to order of n log n. All right, so let us implement this also and see how do we solve this problem. So if I comment this particular solution, which is the brute force, I say here as it is the sorting approach. If I solve it using sorting based, then I simply return here sorted of S. If it is equals to sorted of T, then it will return true, and it will quickly say that it is a valid anagram. And this is the simple approach that we can use here. I submit it once again, and I see here that my time complexity will reduce from 207 milliseconds to directly 17 milliseconds, which means it is much better than the brute force approach. So my dear friends, I hope this video is very much good for you to understand how we are solving pattern-based programming languages. Programming questions, like we solved the two-sum problem, we solved the contains duplicate problem, now we are solving valid anagram, and those all three have the same pattern of solutions. Some things might be different, but the pattern is same. So I hope it is all good. Now I will be coming with the optimized approach in the next video. Till then, signing off, decoding.